In April 2007, a trailer pulled through a gate in the Netherlands and 6 European bison stepped out onto Dutch sand for the first time in hundreds of years. They weren't in a remote wilderness. They weren't in some carefully protected corner of an untouched national park far from human civilization. They were in a narrow strip of coastal dunes wedged between the city of Haarlem, the beach town of Zandvoort, and the sprawling western suburbs of Amsterdam, one of the most densely populated urban corridors on the continent. The Zandvoort racing circuit, where Formula One cars scream around at hundreds of kilometers per hour, was close enough that the animals could hear it. Apartment blocks were visible on the horizon. Motorways hummed in the background. And yet, the 6 bison that walked into that dune landscape in 2007, without being fed, without being managed in any traditional sense, without any human intervention beyond the act of releasing them, did something to those dunes that nobody who studies it can quite frame without pausing at how extraordinary it actually is. They rebuilt it. Not gently, not gradually and barely measurably. They rebuilt it in ways that you can see in before and after photographs and struggle to believe are the same place. Let's start with what the dunes looked like before the bison arrived. Because you can't appreciate the transformation without understanding what the problem was. And the problem was not what you might expect. The Dutch coastal dune system is not a static landscape. It never was. For thousands of years, it was a wildly dynamic environment where wind and sand and large grazing animals worked together to keep the landscape in a constant state of productive flux. Open stretches of bare sand, called blowouts, would be carved by the wind into the vegetation, creating sunlit, warm patches of pioneering ground where the first plant colonizers would move in and the insects would follow. Sea buckthorn and spindletree would take hold in some areas, providing berries and cover for birds. Grasses would spread in others. The whole mosaic, a patchwork of open sand, scrub, grassland, and patchy woodland, created by the interaction of wind and animal and plant, sustained an extraordinary variety of species that each needed a slightly different piece of the puzzle. Then, gradually, that dynamism stopped. The rabbit population in the Dutch dunes, which had once numbered in the hundreds of thousands and whose constant grazing had been one of the primary forces keeping the vegetation in check, collapsed due to the spread of myxomatosis. At the same time, nitrogen deposition from the intensively farmed and heavily industrialized hinterland of western Holland began raining down on the dunes, fertilizing the soil with nutrients that grasses and shrubs could exploit aggressively. Without the rabbits to eat them back, grasses spread. Sea buckthorn, a vigorous nitrogen-fixing shrub that can form impenetrable thickets several meters tall, took over enormous areas. Spindletree crept in. The open sandy patches disappeared under a carpet of encroaching vegetation. The dune blowouts, those dynamic wind-carved windows that had driven the whole ecological engine of the system, began to close over. What happened to the biodiversity in the wake of that overgrowth is what conservation biologists describe as a cascade of losses. When the open sandy patches go, the solitary bees that nest in warm bare sand go with them. When the flower-rich pioneer grasslands disappear under a mat of uniform grass, the specialist insects that depend on those specific flowering plants lose their habitat. When the landscape becomes a monotonous block of vegetation rather than a mosaic of different structures at different stages, the species that required the complexity of the mosaic quietly disappear. Sand lizards vanish. Rare beetles vanish. The birds that depended on the invertebrates those beetles and bees represented vanish. The landscape looks green and alive, but it has become, in ecological terms, an almost empty place. It looks like nature. It has stopped functioning like nature. This is the condition that PWN, the water company that manages the Kransvlak dune area in the National Park Zuid-Kennemerland, was confronting in the early 2000s. PWN's primary job is not ecological management in the conventional sense. It is managing the dune system as a natural water filtration infrastructure, because the dunes between Haarlem and Zandvoort have been used for more than a century to filter drinking water for North Holland. Rainwater percolates through the sand, emerging from the groundwater as exceptionally clean drinking water, and PWN's job is to keep that system functioning. But the overgrowth of vegetation was interfering with that too. Dense shrub cover reduces the evaporation that drives the water cycle within the dunes and changes the hydrological dynamics of the system in ways that were beginning to affect water quality and quantity. PWN looked at the problem and concluded, after years of conventional management attempts using mechanical clearance and controlled burning that simply couldn't keep pace with the rate of regrowth, that what the dunes needed was not more management. What they needed was the return of the process that had originally maintained them. They needed large grazers. The European bison was proposed as the candidate for a specific set of reasons that weren't immediately obvious. Conic horses, a semi-wild horse breed, were already present in many Dutch rewilding projects and were doing useful work keeping grass levels down. But bison have a fundamentally different relationship with woody vegetation than horses do. Horses are strictly grass eaters. They avoid woody plants almost entirely, which means they have essentially no impact on the shrubs that were the primary problem. Bison, by contrast, incorporate woody plants into their diet year-round, and in winter and early spring, when grasses are dormant and less nutritious, they debark trees and shrubs, stripping the outer layer of bark to access the cambium layer underneath. That debarking kills or severely weakens the debarked plant, and bison apply it specifically to the shrubs and young trees that were encroaching on the open areas. 3 bison were released into the Kranzflak area in April 2007. 3 more arrived in 2008. 6 animals. 6 bison into 330 hectares of overgrown dunes adjacent to one of the busiest urban corridors in Europe, with no additional feeding, no supplementary hay, no winter provisions, no management intervention beyond the original act of release. The project, run in partnership between PWN, Ark Nature, and the Stichting Duinbehoud, was explicitly designed as a rewilding experiment rather than a conventional managed grazing program. The bison were not livestock. They were not placed there to fulfill a specific quota of vegetation removal and then moved elsewhere. They were released to be what bison are, and what bison are, it turned out, was exactly what the dunes needed. The first thing the bison did that researchers hadn't fully anticipated in its scope was the wallowing. Bison roll in the ground. They do this throughout the year, rolling onto their sides and kicking up the earth to remove parasites, cool their skin, and dust themselves with the fine soil that helps protect against insects. The wallow patches they create are not small. A single bison wallow produces a circular patch of completely disturbed, bare, fine-grained sand, and bison return to the same wallow patches repeatedly, enlarging them over time and keeping them bare through continued use. In a landscape that had been sealed under continuous vegetation cover, these wallow patches were something the ecological system hadn't seen in years. They were islands of bare sand in a sea of grass and shrub. And what happened on those bare sand patches was the first visible evidence that something remarkable was underway. The bare sand in the wallow patches is warm. It is open to the sky. It has exactly the physical conditions that solitary bees require for nesting. Solitary bees, unlike honeybees and bumblebees, don't live in colonies. They nest individually in burrows. They dig in exposed, sun-warmed, bare soil, and they lay their eggs in those burrows surrounded by pollen stores that the hatching larvae will eat. Many species of solitary bee, including some that are rare or declining in the Netherlands, had been losing habitat across the Dutch dunes as the vegetation cover expanded and covered the bare soil they required. Within a few years of the bison creating their wallow patches, those patches were alive with solitary bees. The bees, in turn, attracted insects that prey on them. The insects attracted insectivorous birds. The first link in an ecological chain that nobody had explicitly designed was forming around something as simple as a bison rolling in the dirt. But the wallowing was only one mechanism. The wind was the other. When a wallow patch creates a gap in the vegetation cover, particularly in a coastal dune system where wind is a constant force, the wind finds that gap and begins to work it. The process is called a blowout. Wind accelerates through vegetation gaps, picks up sand at the edges, and progressively enlarges the bare area. In the Kranzflak dunes, the bison wallow patches began to expand through wind-driven blowouts, opening up stretches of bare dune that were far larger than any individual animal could have created through wallowing alone. The bison planted the seed. The wind did the rest. The combination of animal behavior and physical process, two forces that had been working together in the Dutch dunes for thousands of years before the rabbits declined and the shrubs took over, was reassembling itself. Then there was the debarking. The bison's habit of stripping bark from trees and shrubs, most intense in winter and early spring when grasses were least productive, was targeting exactly the vegetation that management had been trying to control with machinery and labor. Sea buckthorn in particular, the aggressive nitrogen-fixing shrub that had taken over enormous areas of the Kranzflak dunes, was being attacked by the bison in precisely the spots where its structural integrity was most vulnerable. A debarked sea buckthorn doesn't die immediately, but its ability to photosynthesize is compromised, its resistance to disease and drought is reduced, and over a series of winters, repeated debarking kills or severely weakens individual plants and opens gaps in the thicket. Those gaps, once opened, became sites for grasses and flowering herbs to recolonize, and the flowering herbs attracted the specialist insects that had been absent for years. The bison manure was the fourth mechanism, and it operated on the longest timescale, but perhaps with the most profound long-term implications. Every animal's dung contains the seeds of whatever that animal has been eating. Bison range across the entire 330-hectare reserve, and as they move, they deposit seeds at distances from the parent plants that no other dispersal mechanism in the landscape could achieve. Native grass seeds that had been locally suppressed by the sea, buckthorn thickets were being reintroduced to areas where those thickets were opening up, carried there in the gut of an animal that had eaten grasses in another part of the reserve and walked kilometers before defecating. The plant community was being reshuffled and redistributed across the landscape by the movement patterns of the herd, just as it had been for thousands of years before the bison disappeared from Western Europe. By 2017, 10 years after the first animals arrived, the scientific documentation of what had happened was detailed enough to be published in the journal Restoration Ecology and the Journal of the Society for Ecological Restoration. And the results were clear. The shrubs with spindletree and sea buckthorn had decreased or opened up across significant areas of the reserve. More flower-rich grasslands and herbs had appeared. Solitary bees were using the wallow patches as nesting habitat. Sandy paths created by the bison's movement through the vegetation were being used by sand lizards, one of the reptile species whose habitat requirements are specifically tied to warm, open sandy ground that the dune vegetation overgrowth had eliminated. The landscape had become measurably more varied, which in ecological terms means it was now supporting a measurably broader range of species. Roland Vermeulen of Rewilding Europe described the change with a directness that cuts through technical language. At Kransvlak, which is a coastal dune area, there are already a lot more open sandy dunes, which creates microhabitats for other wildlife species to thrive. The phrase, "a lot more open sandy dunes," sounds modest, but in context it represents a fundamental reversal of the trend that had been underway for decades. The dunes that were disappearing under vegetation cover were reappearing. The dynamic process that sustains the entire ecological system of a coastal dune, the interplay of bare sand and wind and colonizing plant and grazing animal, was running again. What makes the Kransvlak result so striking to ecologists who study it is not simply that the bison had a positive effect, that was expected. It's the scale and the specificity of the transformation relative to the input. 6 animals, 330 hectares. No additional feeding, no management intervention. The animals simply lived their lives as bison have always lived their lives, doing exactly what evolution had shaped them to do over hundreds of thousands of years on the grasslands and scrublands of Europe. And in doing so, they rebuilt an entire ecosystem function that decades of active human management had failed to restore. The machines and the labor and the controlled burns had done something, but they couldn't replicate the continuous, year-round, spatially varied, seasonally changing impact of an animal that makes a living from the landscape and shapes it in the process. The difference between managed vegetation clearance and a living animal that wallows and debarks and defecates and moves and creates new habitat with every behavior it performs turned out to be the difference between partial improvement and genuine transformation. The herd grew. From the original 6 animals released in 2007 and 2008, the bison reproduced naturally within the reserve. Because bison, when they have sufficient food and space and are not supplemented with hay, will simply do what mammals do. By 2015, 8 years in, the herd had grown from 6 to 19 animals. Over 25 bison calves have been born within the Kransvlak project since its inception, according to Rewilding Europe's records. As of the most recent counts, 22 European bison were living in the enclosed Kransvlak section of the national park. The herd that arrived as 6 animals is now a self-sustaining community, and as the herd grows, the ecological impact multiplies. More wallow patches, more debarked shrubs, more dung with more seeds dispersed across more of the reserve. The transformation that 6 animals began continues to deepen and expand as the herd that grew from them carries on the work. The broader context of the European bison story is worth dwelling on because without it, the Dutch Dune Project sits in isolation when it should be understood as one chapter in one of the most improbable wildlife comeback narratives in European history. The European bison, known in its native languages as the wisent, was once the largest wildland animal on the European continent. It roamed forests and open landscapes from the Pyrenees to the Caucasus, from Scandinavia to the Mediterranean. The Romans described it. Medieval hunters pursued it. And then, progressively, as forests were cleared and hunting pressure mounted and the human population of Europe expanded into every corner of the continent, the bison retreated, diminished, and finally, in 1927, went extinct in the wild. The last free-living European bison was killed in the Białowieża forest on the border of Poland and what is now Belarus. By the time of that final killing, only 54 individuals survived anywhere on Earth, all of them in zoos. 54 animals, from a species that had roamed an entire continent. And from those 54, only 12 were genetically compatible enough to contribute viable breeding lines to a recovery program. Every European bison alive anywhere in the world today, every single one of the more than 7,000 animals that now roam free across forests and dunes and plains from Poland to Germany to the Netherlands, is descended from those 12 individuals. The genetics of the entire species passed through a bottleneck so narrow that if any one of those 12 animals had failed to reproduce, the species would have lost a meaningful fraction of its remaining genetic diversity, perhaps permanently. The recovery from that bottleneck, through a carefully coordinated pan-European captive breeding program that began in the 1920s and 1930s and produced the first reintroductions to Białowieża in the 1950s, is one of the most remarkable achievements in the history of wildlife conservation. The Kranzevlak project in 2007 was, in this context, not just a local dune management experiment. It was part of the continuing expansion of the European bison's range into parts of Western Europe from which the species had been absent for centuries. The Dutch dunes were not the historical heartland of bison in Europe. They were a new frontier, an environment where bison had never been specifically managed for, but that turned out to match the species' ecological range in ways that researchers only discovered by trying it. The finding that bison could thrive in semi-open coastal dune landscapes without supplementary feeding, in an area surrounded by dense urban development, essentially overturned the previous assumption that European bison were forest-dependent animals that needed large tracts of old-growth woodland to sustain themselves. They didn't need forest. They needed space, food, and freedom to be what they are. The dunes provided all three. In Kent, England, in 2022, 4 European bison were released into Blean Woods near Canterbury, the first free-living bison in Great Britain in thousands of years. The project was explicitly inspired by the Dutch example. The same debarking behavior, the same wallowing, the same creation of open habitat for rare woodland species was predicted to follow in the English context, and early reports confirmed that it did. The Dutch dunes had produced not just a local ecological restoration, but a methodology, a proof of concept that the rewilding of European bison into non-traditional habitats could produce significant measurable biodiversity benefits without any of the intensive management that conventional conservation had previously assumed was necessary. In June 2025, 4 male bison were translocated from Poland to Dutch rewilding sites specifically to enhance genetic diversity, confirming that the project continues to expand and that the genetic management of the population remains an active priority. There's a specific quality to the Kranzevlak experiment that separates it from other rewilding projects and makes it particularly important as a demonstration of ecological principle. The urbanized context is not a marginal detail. It is the point. The dunes where the bison live are not wilderness. They are not remote. They are within earshot of a Formula One circuit. Apartment towers are visible from the dune ridges. The nearest substantial city, Haarlem, is a few kilometers away. Zandvoort's beach resorts are immediately adjacent. And yet, in that sandwich of urbanization, 6 bison and their descendants have produced an ecological transformation that resembles photographs from wild European nature areas 100 times larger. What the project demonstrates is that nature, when it is given sufficient functional space and the right keystone species, does not need to be remote to recover. It needs the right actors. The bison are not just grazing. They are in the ecological vocabulary that researchers have developed to describe what they do, engineering the landscape. They are creating complexity from simplicity, habitat from monotony, biodiversity from monoculture, using the same behaviors and the same ecological relationships that shaped European landscapes for hundreds of thousands of years before humans decided, without meaning to, that those relationships were no longer needed. The dunes of Kranzevlak do not look the same as they did in 2006. They do not look the way that decades of conventional management, controlled burning, mechanical vegetation removal, and careful monitoring had managed to make them look. They look increasingly the way that dunes look when a large, destructive, endlessly creative mammal is living in them and doing what that mammal does. They look messy. They look varied. They look, in the best possible sense of a word that has been overused but rarely deserved more than it does here, alive. And what produced that aliveness was 6 animals stepping out of a trailer on an April morning in 2007 near a racing circuit in one of the most densely developed regions in Europe, and beginning to do what they had always done. The question that ecologists are increasingly asking, in the wake of Kranzevlak and the projects it has inspired, is not whether rewilding with keystone species works. Kranzevlak answered that. The question now is, what is stopping us from doing it everywhere that the habitat exists and the political will can be assembled? The Dutch dune system extends far beyond Kranzevlak. The coastal dune landscapes of Belgium, France, Germany, and Denmark share many of the same ecological characteristics and many of the same problems. The model that 6 bison demonstrated in 330 hectares near Amsterdam is, in principle, scalable to every degraded coastal dune system in northwestern Europe. The bison exist in numbers that make translocation feasible. The knowledge exists, documented in peer-reviewed publications, and in the 17 years of practical experience accumulated at Kranzevlak. The ecological case could not be clearer. What took the Dutch example to overcome, and what every potential expansion of the model will need to overcome, is simply the human hesitation that greets the idea of large, powerful, unpredictable wild animals living in the neighborhood. It's a hesitation that, in the context of everything Kranzevlak has shown, is becoming harder to sustain on the basis of evidence. Yvonne Kemp, the ecologist at RK Nature who works with the Kranzevlak Bison, described the project's philosophy with a warmth and an accuracy that sums up everything the 6 original animals have produced in the years since their arrival. The bison, she said, are essentially bringing back the original biodiversity for free. For free, no machinery. No budget for vegetation removal, no controlled burn scheduled, no hay bought, no winter feeding organized. Just 6 animals, and then their calves, and the calves' calves, turning a dead dune into a living one wallow patch and one debarked shrub and one seed-laden dung pile at a time, doing what bison have always done in a place that looks nothing like where anyone expected bison to be, producing results that look like something nobody quite believed was possible until they saw the photographs and still had to look twice to believe it was real. There's a concept in ecology called the trophic cascade, and it is one of the most powerful and most underappreciated ideas in all of conservation science. A trophic cascade describes what happens when a single species, placed or returned to the right position in an ecosystem, triggers a chain reaction through every level of that ecosystem, changing not just the species it directly interacts with, but the species that interact with those species, and the species that interact with those, rippling outward through the food web in ways that restructure the entire biological community. The most famous example is Yellowstone, where the reintroduction of wolves in 1995 changed not just the elk population, but the behavior of those elk. And the behavior of those elk changed where they grazed, and where they grazed changed the vegetation along riverbanks, and the changed vegetation stabilized the rivers, and the stabilized rivers changed the fish populations, and the changed fish populations changed the birds, until ecologists looking at Yellowstone 15 years after the wolves returned were documenting changes in species and habitats that had no obvious direct connection to wolves at all, but were ultimately traceable to that single reintroduction. Kranzvlak is the European bison's version of that story. The cascades are less dramatic because the dune ecosystem is less complex than a full mountain wilderness with multiple predator and prey relationships. But the principle is identical. 6 bison arrived and did what bison do. What bison do disrupted the vegetation. The disrupted vegetation created bare sand. Bare sand attracted solitary bees. Solitary bees attracted the insects that feed on them. The insects attracted birds. The bison's paths through the vegetation created habitat for sand lizards. The debarked shrubs created deadwood structure for wood-boring beetles. The manure dispersed plant seeds. The plant seeds germinated into flowering herbs. The flowering herbs attracted pollinators. The pollinators visited plants in areas of the reserve where they hadn't been visiting before, pollinating those plants and enabling them to produce seeds and spread. And somewhere in that chain, in some ecological interaction that nobody has even specifically documented yet, a species that was absent from the Kranzvlak dunes before 2007 is now present again because the cascade initiated by 6 bison has reconstructed enough of the ecological architecture of the dune system that there is now somewhere for it to live. This is what the transformation looks like when you remove the jargon and simply look at a landscape that was, 17 years ago, a monotonous carpet of grass and shrub that was becoming more monotonous every year, and that is now a mosaic of open sand and pioneer vegetation and scrub and grassland and woodland edge and wallow patch and wind-carved blowout, each element supporting a different community of species, each community interacting with the others, the whole driven by an engine that runs on bison. The photographs from before and after the project began are striking. The before photographs show a landscape that looks, in ecological terms, like a wall, dense, uniform, closed. The after photographs show what dunes look like when they're alive, complex, varied, dynamic, the way they looked before rabbits declined and nitrogen fertilized everything into a monoculture. The change doesn't look real in the sense that you would not believe it was the same place without knowing the history. It looks like someone replaced the landscape with a different one. What actually happened is that 6 animals replaced the process that had shaped the landscape for millennia, and the landscape remembered what it was supposed to be. Now the project has been running for 17 years. The 6 original bison are gone. Their descendants are there, 22 of them in the Kranzvlak Reserve, plus others in expanded sites around the Netherlands. In June 2025, 4 new male bison were brought from Poland specifically to broaden the genetic diversity of the Dutch population. A reminder that the bottleneck of 12 founding individuals in the 1920s still means that genetic management is an ongoing priority even as the numbers grow towards 7,000 animals across Europe. The herd at Kranzvlak continues its slow expansion of the area's ecological complexity, each generation of calves growing up in a landscape their parents and grandparents created, each generation contributing to the further development of a system that is now unmistakably more functional than the one those 6 animals inherited. What the Dutch bison story teaches us about nature is not complicated. It teaches us that ecosystems were shaped by the animals in them, and that when you remove those animals, the ecosystem begins to lose the processes that depended on them, often slowly, often in ways that look superficially fine, because the landscape stays green even as its complexity and diversity drain away. It teaches us that putting those animals back is not simply a sentimental gesture toward a lost past. It is a practical restoration of functional processes that nothing else can adequately replace. And it teaches us that the scale of animal required to drive those processes, the weight, the strength, the behavioral repertoire, the sheer physical force of a European bison as it rolls in the sand or strips bark from a sea buckthorn, is not a liability in a heavily managed landscape, but a necessity. The dunes needed something that big to do what needed doing. The horses couldn't do it. The machinery couldn't do it. The rabbits, in the numbers they would need to reach to have comparable impact, would require their own ecological management program to sustain. The bison did it on their own, with no instruction manual, no supplementary feed, no management plan beyond the decision to let them be. 6 bison, 330 hectares. No additional feeding, no winter provisions. Just the oldest ecological relationship in European dune history, between a large grazing animal and the sandy, wind-shaped, ecologically complex landscape that it helped create for thousands of years, reassembled in a strip of land between a race circuit and the North Sea, producing results that the people who study ecology for a living look at and describe, with professional understatement, as looking like something that shouldn't be possible. It looks real. It looks like what happens when you stop managing nature and start trusting it to manage itself with the right help. The Kranzevlak project has attracted visitors from conservation organizations across Europe and beyond. The Zuid-Kennemerland National Park now promotes bison watching as a tourist activity. A public footpath runs through the bison area, and the species that was once a symbol of extinction has become, in this small corner of the Netherlands, a symbol of something much rarer in conservation. Unambiguous, measurable success.